In this video, you're going to learn how to add and subtract fractions, which is one of the most common skills in mathematics. Don't worry, the notes that you're seeing on the screen will be in the link in the description below. We're also going to cover 4 examples together, and I'll leave you with 4 more to practice on your own with the solutions in the description. Now, without further ado, let's get to it. If you're new here, my name is Olivier and I'm a certified math and physics teacher in Ontario who is currently doing a master's in statistics at Carleton University. The first thing we need to add fractions or subtract fractions is a common denominator. And here I just want to remind you that my hand is broken, so that's why my writing is extra bad. And you might hear some Velcro sounds, that's just the sounds of the brace. And ideally, this common denominator would be as small as possible. We don't want a huge number, because we can get big numbers, but we want it as simple as possible. So I'll just write, we want the lowest common denominator. So the way to do this, to get this common denominator is, let's say we have 2 abstract fractions here, a over b plus c over d. Well, we multiply the denominators. So what do I mean by that? Well, it would be a times d, so we multiply it by the other denominator, and we do it times d on the bottom. Why do we do this? Well, we have d over d, which is 1, so it's something. So I'll write a box times d over d. Anything divided by itself is 1, so we have box times 1, and anything times 1 is just itself. So we're allowed to do this. It doesn't change the a over b. And then we just do c over d. But this time we multiply it by the other denominator, which was b over b. So then really what we have is AD, because that's a times d, plus CB or BC, if we write them in order, over BD. Note that I didn't add the denominators, I just wrote them all together, and we could do visuals to get an intuition for why this is true. Now, with the wrong way, there's many wrong ways, but one of them would be a plus c. We just add them over b plus d. Note that this is not the case here. And it wouldn't be bd plus bd in the bottom as well. That doesn't work. I don't want to spend too much time on the theory. We could draw a bunch of drawings, but let's do a bunch of examples, because to me, that's really the best way to build some intuition here. We have 1/2 plus 2/5. 1/2 is 0.5 and 2/5 is 0.4. We know it's going to be 0.9 at the end, or 9 over 10, something like that. To do this, we need a common denominator. So how do we do that? Well, we multiply the denominators together. So we have 1 times 5 over 2 times 5. So note that the bottom is over 10. That's good. And we have 2 times 2 over 5 times 2. This is 5 plus 4. This is over 10. This is over 10. We have our common denominator. And this is 9 over 10. And this would be 0.9 if we put it in decimal. But we don't need to do this here. Subtracting fractions is the same thing. We need a common denominator. And in number b here, we already have a common denominator of 4. So we just subtract the numerators. It's not 4 minus 4, because then it'd be divided by 0. It's just 4 in the bottom. 3 minus 5, well, let's say we have a number line. And with minus, that means we move 5 to the left. So 2, 1, 0, -1, -2. So we have -2 over 4. Note that -2 over 4 could simplify, because we can rewrite it as 2 times 2 in the bottom. 2 times 2 is 4. And when we cancel the 2, we have -1/2. So that is -1/2 or 0.5. -0.5 if we put it in decimals. You could also make a little drawing to show that it would be -0.5. So for example, if we have a chocolate bar split in 4, so that means there's 3 lines, and we have 3/4, and we take away, so that this is what we have 3/4, and we take away 5/4. So I'll make 2 other chocolate bars, again with 3 lines. And let me just draw in what we have here. We have 5 pieces. So 5 here and 3 here. Well, then we would take away 2 more quarters, right? Because a 3 would go away and we'd be taking away 2 more quarters, which is really half a chocolate bar in the end. Now, if we move on to example C here, again, we're adding fraction and we need a common denominator. You could multiply the denominators like we did in example A, but that wouldn't be the lowest common denominator because 3 times 6 is 18. However, if you do times 2 in the first fraction, you get a common denominator of 6. So let's try this. And I'll show you both ways so you see that they both work here. Let's say we just do 2 times 2 and times 2 here, plus 5 over 6. That means we don't even need to change the other one. So that would be 4 over 6 plus 5 over 6. We have our common denominator. That's good. Now we just add the numerator. So that would be 9 over 6. This could be simplified. So for example, if we divide by 3 and divide by 3, we would have 3 over 2, which is equal to 1.5. And we could do the other method, so that would be the lowest common denominator. But we can also do by just multiplying the denominators, and I'll show you why this is a little bit less efficient. So for example, if we just do times 6 times 6, and then we need to also do times 3, so you can already see how it's more work. So then that would be 12 over 18. That's the same fraction as 4 over 6. Which makes sense, they're equivalent fractions. And then it would be 15 over 18, which is really 12 plus 15 is 27 over 18. We can divide both by 9, which would be 3 over 2, which is again 1.5. You see how they both give the same answer here. So far, we've only worked with an addition or subtraction of 2 fractions. But in example D, we're going to subtract a bunch of different types of fractions. So this 1 and 1/15 would be a mixed number. So that complicates things a little bit. But if we just apply the same principles, it should work. So the first thing I'm going to do here is I'm going to write every mixed number or number as a fraction. And then we're going to try to get a common denominator. So 3/5 we can just leave it as is. And then the way we convert a mixed number to a fraction is we multiply the 1 and the 15th. So that would be 15th. 1 is 15 over 15, right? So, and then plus 1/15. So that's really 16 over 15. That's 1 and 1/15. The 7 over 6 is already a fraction. And minus 1 is really 1 over 1. Now, if we move on to step 2 and we need to find the common denominator, it's not so obvious here because before we just multiplied the denominators together, but here we have 3 denominators and technically 4 is just that 1 won't change the outcome. So if we multiply all the denominators, so 5 times 15, that is 75 times 6. I can't even do that in my head rapidly. So imagine adding and subtracting all the other numbers. It would probably work, but it would take a lot more computational power from our brains. So instead, we can try to look for a lower common denominator. So for example, if we do times 3 to the first fraction, we would get 15. So then we have a common denominator. However, when we look at the 6 in the next fraction, 6 doesn't go into 15 properly. So then we need to maybe go to the next multiple of 15. So what about 30? Well, 5 times 6 is 30, so that works. And 6 times 5 is 30, so that would work here. If we take 3 over 5, then we would do times 6 over 6. 16 over 15, then it would just be times 2 over 2. And then minus 7 over 6, that would be times 5 over 5. And note that I'm multiplying by 1. 6 over 6 is 1. 2 over 2 is 1. 5 over 5 is 1. And then here, minus 1 over 1 would be, really, it'd be times 30, because we want 30 over 30, and that's 1 as well. So then if I just do the multiplication, I have 3 times 6 is 18 over 30, plus 32 over 30 minus 35 over 30, and then minus 30 over 30. Oh, I wrote 32 over 32. I wrote all the fractions separately, but I could have went ahead and put them all over 30 right away. If I just write them all in one fraction, I have 18 plus 32. That would be 50, and then minus 35 minus 30, all over 30. So then that would be 50 minus, if I combine the two negatives, that would be minus 65 over 30. So really that's minus 15 over 30. Or if we divide by 15, that's minus 1/2. Or if we convert it to a decimal, it's negative 0.5. So you see how a bunch of ugly fractions like this can simplify to something pretty nice like negative 1/2. I included 4 exercises for you to practice on your own. And don't worry, the solutions are step by step in the description below. And you can always comment your questions in the video here on YouTube. The best way to support the channel currently is to like this video, hit the subscribe button, but really it's to share this video with your friends and anyone that you think might find it useful. If you've enjoyed this specific video, you'll probably enjoy the other fundamental mathematics video I've added on the playlist on the screen. As always, thank you for watching, and I'll see you next time with Do the Work.